Hi all, welcome to my channel, and today we will solve this LeetCode problem 198, house robber. So as per the problem description, it is given that you are a professional robber planning to rob houses along a street. Each house has a certain amount of money or stashed. The only constraint stopping you from robbing each of them is that adjacent houses have a security system connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. So you cannot pick on two adjacent houses, and so you are given an array of integers, so representing the amount of money each house has, and you have to return the maximum amount that you can rob without alerting the police. So as an example, first example, you can either pick one or three or two or one not adjacent ones. So the output will come the maximum between these two, that is 4, right? And similarly here the maximum is 2 plus 9 plus 1, that is 12. So we have this constraint like number can be between the array between will have this length between 1 and 100, and the number will have a value between 0 to 400. So we cannot directly pick alternate and decide like this, okay, this is odd number sum and even number sum, and we have to return the result like max between these two. So this is more of a we can use recursion or iteration to find out all the possible solutions, because in this example, if I show you this 2 1 1 2, so you have the first house with money 2, and second house 1, third house 1, and fourth house with 2. So if you pick this alternate only, then you will end up having a result of like 3 here and 3 for these two houses, right? But the maximum that is possible is this one and this one, so that is 4. So the approach to solve this problem is, if we take this random array 2 3 1 1 5 3 2 8, something like this. So and you are a robber, let's sketch this out, and you visit this house, first house. You don't know how many houses are there, and you see this house has this money, and you encounter this money and you just directly pick it, because that is the maximum amount that you can pick till now, right? But if you go across this and see this, there is 3 values there, right? So then you don't want to pick this, okay, and you want to pick this. So the second value between how you're picking is simply the maximum out of the first and second values, so that is 3 here. Now if you encounter the third house, then you will see which is having the more value, like this house and this value that you have collected till the last to last house, or the last house value, because you cannot pick this if you have picked this, right? So either you sum this, so that is 2 plus 1 3, and this is 3, so you can take either of it, so that's not a problem. So the maximum amount that is possible till now is 3, okay. And so you move forward with the fourth house, and you see you have money this. So if you are picking this, you cannot pick this house, right, this result. So you have to pick this result, that is 5 plus 3, that is 8, and you have to compare it with the last house value, that is 3. So till now the answer will be 8, comparing 3 and 8 is maximum, and so on. If you move forward, 3 plus 3 is 6, then 8, then you have to pick on 8 only. Then going forward, you encounter 2, okay, 8 plus 2 is 10, and this is 8, so the answer is till here is 8. And so 8 16 or 10 we have to. So we have to write this algorithm so that it ends up having, so this array will have last index element as the maximum element that can be robbed, that is the maximum value that you can rob, right? So this is 8 5 and 3, that is So these random houses that we have picked, and we got this answer at 16. So if we go write the algorithm, so the first so what we will do is we will not use any separate array. We will keep updating the original array itself, and so that we don't use any extra space, and optimize the solution as much as possible. In a single iteration we will solve it. So the nums 0 is already 0, so we have to take care of nums 1. So before accessing that, we can also have an array that has length of 1. So in case length is 1, we can simply return the first index value, that is nums length. If it is equal to 1, then return simply the first value that we have. Otherwise the length will be greater than and as per the constraints given in the question. So for the second index element, so basically this is the second element, this is first index, second element, math.max between the current element and the previous element. I hope you are getting it. So now for next elements, we have to iterate on this from second element to end of the length, and then we have to update the array as nums of, so we have to pick maximum for current element plus between, and then there is this last element. Either we pick the last element or the current element with n-2 value, right? So we have to pick on that way, and the last element of this array, updated array, will have this maximum value, right? So we can simply pick nums length minus. Okay, so this is our solution. If we give this, paste this, run this, yeah. So it seems to be running fine. Run with the more example test cases. Okay, so it failed like 3. Okay, I did some mistake here. I should have given -1, right? Because this is the last index. And now run with the example test case. Okay, so this is our solution. I think if we submit it, the runtime is 0, is much more faster. This is the most efficient solution that I can think of now. Yeah. Thank you all for watching.